prefix equalities. Students are encouraged to memorize the highlighted prefixes as soon as possible. Later in the course, it won't be possible to be successful without a working knowledge of the prefixes. It's important to understand not only the letter or symbol for each prefix, but also the multiplication factor and what that means. First of all, to interpret the chart, I like drawing a line in between deca and deci. This is the place where the base unit exists. The base unit of length is the meter, the base unit of mass is the gram, base unit of volume is the liter. At the blue line, we have 1 meter, 1 gram, or 1 liter, respectively. If we're looking above the blue line in the chart, these are the prefixes that denote multiple base units. For instance, kilometer would be 1,000 meters. Below the blue line, all of these prefixes are a fraction of the base unit. For instance, a centimeter is 1/100th of 1 meter. It's generally useful to take a look at what I call metric prefix equalities. Are we able to write two equalities that connect the base unit mass with the prefix kilo? So for instance, we might start with 1 kilogram. We're wondering what we can write that's equal to a kilogram in terms of the base unit. And it turns out in looking at our chart, we realize that that's 1,000 grams. If we wanted, we could use the logic writing it in terms of one big unit. We could start by writing it in terms of one small unit, in this case the gram. If we write 1 gram, that's actually equal to 1,000th of a kilogram. I like to use my mental voice to examine each prefix equality to make sure that it makes sense. In the case of the top equality, I have one large one equaling lots of small ones. On the bottom, it's the reverse logic. One small one is equal to a fraction of a big one. One thing that absolutely wouldn't make sense is to write 1,000 kilograms equals 1 gram. And as soon as we use our mental voice to think about this, again, lots of big ones in one small one, we realize that it doesn't make sense and it shouldn't be written. If we're going too fast, we may miss that, and in that case, our work will be riddled with small mistakes. To try another example, we might look at mass and micro. At this point, we need to take a look at that prefix letter or symbol mu. This is a Greek letter that kind of looks like a funny looking U. Also, I'd like to take the time to make a suggestion at this point. I would advise that you be consistent in the way that you write your metric equalities. Always write in terms of one big one or in terms of one small one. So for instance, I might like to write one big one is multiple small ones. And the example would be 1 gram is 1,000 milligrams. This tends to be the way that I like doing it. However, because of exponent rules, there's another way that we could write the very same equality. We could say that one small one is a fraction of a big one. The example in this case would be 1 milligram equaling 1,000th of a gram. Either way, we find because of exponent rules that the equalities are actually equal to one another. But again, I think you should always choose which one you like best and stick to that method. Is it writing in terms of one big one, or is it writing in terms of one small one? Back to the example at hand, again, mass and micro. I tend to prefer writing in terms of one big one, so I'm going to start with 1 gram. I'm going to set that equal to 1,000,000 micrograms. In my mental voice, I say that one big one is equal to a lot of small ones, and that ends up making sense. Maybe you're someone who likes to write in terms of one small one. If you write in terms of one small one, you're going to be setting that equal to 1,000,000th of a big one. Again, mental voice, one, small fraction of a big one. Now you try. Select any three combination of base units and metric prefixes. We had just done 2 examples of this. Write 2 equalities for each one. This will be a total of 6 equalities. It's important to share your work with a peer. Get feedback.